concentrating on society-driven research and many other facilities. On behalf of our department, I wish to welcome today's speaker, Dr. Harish Puleria, Assistant Professor, IDP in Climate Studies, Indian Institute of Technology, Bombay, Mumbai. Sir will be delivering a lecture on urban noise pollution, sources, impacts, measurements, and control. I welcome you, sir. I also welcome all the participants to today's session. I welcome Dr. Dayananda HS, Dean Academics, Dr. S.K. Prasad, HOD, Department of Civil Engineering, and all my colleagues of UVC, both from teaching and non-teaching community. I welcome one and all. Over to Madhushri Madam.
Thank you, sir. May I now request Professor Sharmila A. to introduce today's speaker, Dr. Harish Puleria. Over to you, madam.
Good morning, one and all. It's my immense pleasure to introduce today's eminent speaker, Dr. Harish C. Puleria. Dr. Harish C. Puleria, Assistant Professor in Environmental Engineering and Engineering Department and Associate Faculty in an Interdisciplinary Program in Climate Studies at IIT Bombay, where he spends about equal time in teaching and research. Dr. Puleria has received BSc, MSc in Chemistry from University of Delhi and IIT Delhi, respectively. MTech in Environmental Science and Engineering from IIT Bombay and PhD in Environmental Engineering from University of Southern California, Los Angeles, USA. Dr. Puleria has 15 years of experience in aerosol measurements, chemical characterization, and air quality assessment, and 10 years of experience in air pollution and noise exposure assessment, air quality modeling, and air pollutants health effect assessment. Before moving back to IIT Bombay, he worked at Swiss Tropical and Public Health Institute, University of Basel, Switzerland. His primary research is directed at quantifying and characterizing the short and long-term exposure to different environmental stressors such as air pollution and road traffic noise. His specific interest lies in characterization, new exposure, that is to ultrafine particles, to brown and black carbon, and to chemical constituents in aerosols, particularly of traffic origin. This is the brief introduction of Dr. Puleria, sir. Thank you, sir, for being with us. I once again welcome you, sir. Over to Madhushri, madam.
Thank you. Before moving on to the session, there are a few announcements. Participants, for your kind attention, please. E-certificate will be issued to all the participants at the end of the session after you submit your feedback form on the daily basis. E-certificate for 1 week faculty development program will be issued to the faculties only who have actively participated in all the sessions and have submitted your feedback form. Further, any instructions and details regarding the program will be shared through Telegram or through your registered email IDs. Feedback link will be put up only in the YouTube chat box. I repeat, the feedback link will be put up only in the YouTube chat box. Participants, if any queries related to the session, you can put up in the YouTube chat box and will be answered by the speaker at the end of the session. Thank you. Without any further delay, we'll move on to today's webinar. Over to you, sir.
Okay, thank you, VCE, all the organizers. Good morning, everyone. It's a pleasure to be here and interact with you and share some of my work and thoughts on one of the important problems in environment, which is related to noise. So let me just share my screen with you. I hope this is visible. Okay, great. Okay, so we will be talking about environmental noise. And here, the emphasis would be to understand what are the sources of noise, what are its effects, how it can be measured, and most importantly, you are in civil engineering department, so all engineering people, I think one of the important tasks is to control them. So we'll talk about that. So to begin with, noise is something that all of us are aware about. But essentially today, we are going to focus on environmental noise. So what do we understand about environmental noise? For example, like we know about like where the noise is coming from, loudspeakers. We know that the noise affects us. We can get annoyed. We can feel pressure in our ears if there is loud noise. We can feel stressed sometimes, night arousal, or we are not able to sleep. Could be some of the effects. Stress, increased blood pressure. Some of those things could be also because of noise. So what is environmental noise? So environmental noise is what we are going to talk about. It is those sources of noise in the environment which directly impact us and which are anthropogenic in nature. So we are not talking about the natural noise. For example, we are not talking about birds chirping or, for example, anything which is naturally occurring. We are talking about man-made. So mostly when we talk about environmental noise, we are talking about transportation, which is road traffic, railway, aircraft, construction, these kind of noises. Okay. The next thing is, why do we specify noise types when we talk about noise pollution? So this is something that you should think about. See, when we talk about other pollutants in the environment, let's say air pollution, waste, solid waste, water, we do not talk about the source. We just measure at the receptor and say that, okay, what is its quantity in mass per unit volume, mass per unit mass, something like that. But when we talk about noise, it is always source specific. We cannot say that we have 10 decibel or 50 decibel of noise. We can say that we have 50 decibels of noise which is related to road traffic. And we will talk about why that is so. I think then the important question is, where and when do we encounter environmental noise? I think all of us on a daily basis encounter this. Of course, during this COVID-19 disruption, our lives have very much changed. We are many times working at our home. So our exposure to environmental noise has definitely reduced. But we know that when we typically work on a normal day, we always encounter a lot of environmental noise. Question is, why are we concerned about it? So I mentioned, for example, it is related to, for example, not only blood pressure or heart-related ailments or effect on ear, also it has impact on cognitive ability. For example, those who are working with any task which require attention, for example, students in the classrooms, kids in the classrooms, or teacher teaching in or professors teaching in courses, you need a good environment. Any noise will disrupt the flow of the information and the task people are doing. Or even when we are thinking about, when we are writing something important, we need a quiet environment. So we know why we are concerned about that. I think this course is about sustainability, and most of you, or all of you, I guess, are from civil engineering department. So I think we need to also look at what is the link of the environmental noise with sustainability. We'll talk about that. So after having all of that said, I want to emphasize that today we will be discussing about the sources and effects of transportation noise. And that means mostly road traffic and a bit about aircraft and railway noise and how it can be measured and controlled. Okay. So let's talk about sustainable development goals. I think you know SDGs. There are 17 SDGs which the United Nations have defined. You can see them here. Question is, which SDGs are associated with environmental pollution? When I'm talking to civil engineers, there is already like a dedicated, part of your program where you are also looking at environmental problems. So that's why we are talking about environmental pollution, which could be in any kind of domain. It could be in air, it could be with water, it could be with solid waste, and it could be also with the noise environment. So essentially, when we are talking about the SDGs association with environmental pollution, it is related with number 3 most of the times. For example, which is good health and well-being. So you all know that a polluted environment is not good for our well-being, both physical as well as mental well-being. And all kind of environmental stressors, noise, air pollution, water, any toxins in our food, pesticides, right, toxic waste, all of those can affect our health adversely. So it is important to appreciate that all of us and even the civil engineers, our goal is to lead to a sustainable society where environmental pollution is controlled. We have a good and serene environment which helps and allow us to function, and to do our job as efficiently as possible, and our healthcare costs are reduced. So that is the link with the SDG with environmental pollution. In terms of noise, just few facts here. About 1 million people affected in China due to environmental noise, and almost half, you can say 40% of people at work have noise levels more than 85 decibels, which is the guideline for occupational noise at the workplaces. And about 10,000 people prematurely die in Europe due to noise pollution. Now you might be thinking that that's a very small, meager number. When we are talking about billion of people, 8 billion people in the earth and about 1.3 billion in India, these numbers look like very small. But know that these are exclusively attributed to noise pollution. And these are like deaths, for example. And they can cause a lot more problem in terms of disability, in terms of hearing, not able to hear properly, and affect and disrupt our life. Okay, so it is not limited to the small number of deaths, for example. Just to give you an idea, if you look at India and look at the environmental risk factors and Delhi. So Delhi, for example, is the disability adjusted life years. So for example, you see here like from birth to when people die. So if there are people who have some disability and they live before they die, and let's say if this disability was not because of any of these exposures or risk, then they would have, for example, lived up to here, like expected years. So if you add these two, the years lived with a disability and the years lost because of any harmful effect to the exposures or risk factors, that is called Delhi, right? So that is basically shown for India here. It is shown for different states in terms of different environmental factors like water, sanitation and hygiene. You can see that is the top one here. Air pollution, the second one. Other environmental, noise is one of the important one here. And occupational risk, which could be including accidents plus also including any kind of amputation. It could be also accidents which can lead to disability, even also sometimes premature deaths. So what you see is that all of them can cause Delhi's of the order of, and you can see by state, at least few thousand. So this is like few thousand years lost, okay, per 100,000 population. So if you take the whole state's population for each one of them, you can see the amount of impact these kind of environmental stressors can have, right? So just to keep that in mind. Okay, so that was the background. So what are the learning objectives today? We will learn about what are different environmental noise sources. Why are we concerned about noise, and specifically auditory and the non-auditory health effects. In case of noise, it is very important because you all know we hear through our ears. So the noise impacts first our auditory system. So we will look at what are the effects of noise on our ears and our hearing ability, and then also the other effects on health. We will look at how is noise measured, what are some of the regulations. Very important in case of noise is what is called occupational noise exposures, because I think like many of you have already experienced that. So those who are working in construction business, those who are working in industries where heavy machineries are used, or for example, those who are, driving every day, postmen, to, traffic services, to, for example, courier services people, all of them are exposed to noise, which are very high level. And these high level of noise are because by virtue of them being into certain occupation. Many of us may not be exposed to those noise for long period, but some people who have such kind of occupation, they may be highly exposed. So we need to distinguish between environmental versus occupational noise. And as I said, very, very crucial is how can we control noise pollution exposure. So these are some of the things that I hope I would be able to run through today during this lecture. Okay, before we go further, I just want to mention, most of you are teaching, so I think it is always important to know what are the resources available. I want to really suggest, looking at this book, which is by Davis and Cornwell, which is Introduction to Environmental Engineering, and specifically chapter 10, which is dedicated to environmental noise. So you want to look at that. And at the same time, there are a lot of web resources which are available. I'm just listing a couple of them here. One of them is, for example, Iowa State University, and another one is from the Washington State Department of Division of Occupational Safety and Health. And some of the slides also are either taken or adapted from there. So if you are interested for more information, please visit these two websites. It has a lot of very, very good information and very relevant. Okay, with that, let's move. Some of these first few slides are very basic. They are from maybe class 10th, even 8th, 12th, just to kind of, talk about it. Because what happens, if you see, while all of us are being exposed to noise, I don't think we are being taught or like a great attention has been looked at it. For example, all the time during festivals, during some religious processions, during Diwali, we have very high noise levels in communities, right? For example, in India specifically, and most of the developing countries, or you can say low and middle income countries, the price of the land is higher near roads, which is not the case in the Western countries. Actually, the price of the land increases as you move away from the roads, because the roads are a great source of air pollution and noise. And that's why those who are living near the roads, they are adversely affected to both of these stressors. So, but in India, it is the other way around. And reason is because we have not been paying much attention to environmental noise and what are its adverse effects. So let's just kind of briefly look at that. So first of all, what is the difference between sound versus noise? Like sound, noise is kind of a sound also. And what is sound? It's like a pressure change, which can be detected by our ear. It could be human ear, animals, all those have, these senses, so they can hear it. And generally the pitch ranges, the frequency ranges between 20 to 20,000 hertz. And the volume, which is loudness, ranges from about 0 to 140 decibels. This is a typical anatomy of human ear. You can see this is like the outer part of the ear, which is just to give the directionality so that the sound waves are basically directed towards the ear canal. And then they go to this middle ear, and which are connected to the inner ear. Inner ear has like some of the neurons are attached, and basically they kind of now feel the pressure difference. And the change in the pressure is detected and converted into a cognitable signal. For example, the pressure change is about like, okay, something is being said, and then based on the difference in these pressures, we convert them into words or some kind of sensing. For example, is it like a cry? Is it like something being whispered? So basically converting this pressure signal into some kind of cognitive signal. So you can say noise is a type of sound. It is generally undesirable and unwanted. So for example, like you may see kids or essentially adolescent people, or the children who use all the time some kind of earphones hooked with their mobile phones, or some kind of PlayStation, and they may actually run at very high level noise, but they are listening to some kind of a music and they don't think it is noise. They think it is a pleasurable sound. So when it is not just about the loudness or the pitch, it is about the undesiredness. Like we don't want something, and if it is noise, then, and if it is sound which we don't want, it's called noise. It carries almost no information. We actually process it, and mostly it is random. So it is a manifestation of vibration which are travel in wave patterns through any medium, solid, liquid, and gas. And these waves caused by vibration of molecules follow essentially a sine function, which you all know, which looks like this. For example, here on the y-axis you have pressure, which is essentially converted to the loudness, and on the x-axis you have time. So this kind of gives you the amplitude, and this like horizontal kind of tropes, and the difference between them gives you the period or the wavelength. For example, if you see here, these are different sound waves which have the same amplitude, same loudness, but they have different frequency. For example, when we are moving from up to down, the frequency is increasing. That means the voice is becoming, loud to very shrill. So that's what the difference in the noise. A little bit about the measurement units, because it has a very specific unit unlike any others. For example, bells and decibels are the units in which noise is measured. And it is essentially the sound pressure level. And as I mentioned also earlier, a normal healthy individual can hear a sound pressure about as low as 20 micropascal to about 200 pascal, which is, for example, for a space rocket, right? Now, this unit Bell is coming from the great Scottish, scientist Graham Bell, which you all know was the inventor of the telephone. So in his honor, the unit of the sound is basically measured in Bell, which is essentially the logarithmic of the sound pressure ratio. And you can see that we have 20 micropascal, which is 20 into 10 to the power minus 6 Pascal to 200 Pascal, which is almost 8 to 10 orders of magnitude. So this is a very large range. So we take logarithm of that so that we can manage these numbers. Okay, so that's why we take a log of that. You can see here. So if you take the log of pressure, for example, to a reference pressure, that is giving you a bell. And if you just divide it by 10, that is decibel. That is how noise is measured. So, okay. Now, this Q could be a quantity, could be a pressure, could be energy, right? So it could be that. It could be a force, the way we want to describe it. For example, when we are measuring it as a pressure, we can, as you have seen the sine wave, if we take the absolute values, they will cancel each other. So we take the root mean square, a sum of that, and then basically use the formula, which was how the bell decibel is defined, right? So this gives you the noise measurements. And as I said, the unit is explained in decibels, and the reference pressure, the P0, is 20 micropascal, which is corresponding to 0 decibel. This is giving you the typical environmental levels of noise and the corresponding sound pressures. You can see that here down, your left hand side, you have the pressure, for example, 20 micropascal. This is corresponding to 0. That means no hearing. This is the threshold of hearing. We cannot hear below that. You can go upward a bit. For example, it's about 200, 300 micropascals, which is about 20 or so decibels, is about like a quiet bedroom. For example, in library, you can have about 40 decibels. And you can see a jet engine, for example, can have 100 million micropascal, right? Or 100 Pascal, which is corresponding to almost about 140 decibels. If you just see it in general, like the levels, for example, up to about 55, which is the standard for daily noise levels, below which we say that it is okay, there is no adverse health effects. Above that, you have unhealthy kind of environment. You can see even a conversation could go up to 60 decibels. A car, passing nearby can be 70 decibels. A telephone ringing, of course, we do not have these kind of telephones anymore. But like, even a simple mobile phone with high volume can be about 70 to 80 decibels. Truck 90, and similarly aircraft takeoff could be almost towards the threshold of pain, which is about 120 to 130 decibels. A bit about noise regulation. So for example, we have noise rules as in 2000, which is under the umbrella Environmental Act, which is Environmental Protection Act 1986. And you can see that here you have categories of areas, for example, industrial areas, commercial areas where a lot of commercial activities are happening, shops are there, residential areas where people live, and we have also what we call sensitive or silence zones. For example, hospitals, schools, some of those areas. This could be also ecological parks, which are prohibited. So these could be the sensitive zones. And for each one of them, there is like a daytime and a nighttime noise regulation. For example, industrial areas, 75 decibel on an A weighing. I will tell you shortly what that A means. And you can see here, for example, residential areas, 55 decibels is during the day, 45 decibels is during the night, right? And the day is defined from 6 a.m. to 10 p.m. Night is defined from 10 p.m. to 6 a.m. Okay, so that just to keep in mind. As I was telling, like the human ear can hear a range of frequencies, but in a domain which is pretty fixed. For example, we looked at how the decibel scale is from 0 to 140 decibels and from 0 hertz to 20,000 hertz. But for example, if you look at human audibility, it is in a very narrow range. For example, from 16 hertz to about 20 kilohertz. That is the human audible range. For example, something which is beyond 20 kilohertz, some of the animals can have that sensitivity. In the ultrasonic range, they can, hear it. On the other hand, for example, some animals may also hear in the subsonic range, which is really, really low, very low frequencies, like less than 16 hertz also. But human ears are mostly in that range. Now, I said that we measure generally the noise in decibels, but then we also add a weighing scale, which is called dBA. The A weighing, we use that. And that is because our human hearing is sensitive to a certain range of frequencies. For example, this graph is showing you the frequencies in hertz from 20 to 10,000. And this on the y-axis showing the relative response of human ear to those frequencies. For example, what it is saying is, if you are taking, first of all, human ear is mostly sensitive to this range, from almost like 500 to almost 10,000 or so. That is the range where the human ear is more sensitive. That is the range where most of our conversation happens. Most of the sounds are only in that range. Okay. So it is important that we tune our measurements according to that. So the first scale, which is dBA, is adjusted overall to scale down the frequencies which are in the lower range. For example, even if you have a high noise, high loud noise in the low frequencies, because we are not able to hear that well, so we downweigh it. But for example, those which are in this range there is no relative response. We are saying that if it is 0, it is 0. For example, right? So the dBA is really to tune the absolute noise frequencies towards our hearing ability. There are other scales like dBC, which is basically to adjust only for the loud or low frequencies, and also a B weighing, which is almost like in between the two, which is rarely used. So most of the times we are using dBA for all purposes. dBC also sometimes for measurement, for engineering controls, and some of those we also use dBC. Okay, with that, let's move a little bit about seeing that what kind of noise levels do we have or we find in the world. You remember I mentioned that 55 decibels on the x-axis, you can see this is the range of noise levels in the dBA scale. So 55 decibels is the daytime noise and 45 is the nighttime. This is basically showing you the average. And if you see here, from, for example, many of the countries in Africa, in Asia, to, for example, in Europe, to US, you can see that in most of the cases, you see that the noise levels are always exceeding 55 decibels, which is the required regulation for ambient noise. And except, for example, one of the cities here, you can see all of them are exceeding that. And more likely, you are seeing that in developing countries, we have even higher noise levels, compared to some of the other countries. And the reason is clear, right? Why do we have higher noise levels? Because even if we may have regulations, they are not well enforced. That's one thing. Second, we are not well aware about the adverse impacts and how much it costs us, because most of the times our cost benefit is not taking into account the healthcare costs, the disability, the loss we have because of the impact either on conscious or the subconscious mind because of the noise level exposures. If we just look at India, for example, in this figure, you can see excess is again showing you the noise levels from 40 to 90 decibels. And these are different cities. The symbols in the bracket, like C is commercial, R is residential, T is traffic junction. So you can see most of them are residential and some of them are commercial and traffic. And again, you can see that all cities, the noise levels are exceeding 50 decibels, or like except one, which is Delhi, which is very surprising. And it depends because it was in a Delhi residential area where probably there was not much traffic. And that's why this is the case. But most of the time you see that it is about 60 or higher. So that is what, for example, in one of the studies where like we basically consolidated and we found that. I was trying to look at what kind of noise levels are there in Karnataka, because that's where you live and that's where you want to really see. It's interesting that all the data which I was able to look at and able to find is restricted to only one city, which is of course a mega metropolitan city, which is Bengaluru. And you can see that, for example, it is constantly being highlighted, in the last decade. For example, in 2014 in Hindu, you can see that noise levels at 5 noise monitoring stations. And you can see that they are all the time, max levels are exceeding. And you can see that many of the levels are higher than the prescribed limits. And if you also, and you can see like shrill horns are reported, right? Use of horn in silent zones, which is actually, prohibited, was done. If you fast forward, come to 2018, still you see that many of the places in Bengaluru have, you can see these 86, 74, 96. These are the decibels. And you can see these are the regulations, 50 for silent, residential 55. So almost all of the city, we have noise levels far exceeding than the regulation. And also if you look at the recent 19 February 2020, so the Karnataka State Pollution Control Board basically agreed to map noise pollution hotspots, right? And this is like together with additional 45 cities, which Central Pollution Control Board has identified as a response to the directive from the National Green Tribunal. So I'm just highlighting that environmental noise also is basically becoming important and, at the spotlight, once the monsoon is gone and we are, like not talking about the road conditions, potholes, clogging of our sewers, then winter will come when we are going to talk about air pollution. And then in between, most of the times noise pollution are always there, so it is important to note that. I also tried to look at, certain trends. For example, in Bengaluru, you can see here, this is like a year-long data of noise, which is measured at 4 sites, a sensitive site, which is the first bar, the 2 residential site in Domlur and BTM layout, and a commercial site. And these 3 lines are showing you the regulation. For example, for the sensitive, it is 50 decibel daytime. It is 55 decibel for residential, and for commercial 65. You can see almost all areas are exceeding the regulation during the daytime across the months. Doesn't matter which month we are talking about. For example, compare that with air pollution. Air pollution is mostly not a problem during the monsoon months. It may be a less of a problem in the summer months, but you can see noise is all the time throughout. If you look at nighttime, the story is very similar. You can see that the regulation are 40, 45, and 55 for sensitive, residential, and commercial. And you can see again, all areas are exceeding the noise levels far high. Some of them are almost as high as that are regulated in the occupational environment. So this is really, I think, important to note. Now, one of the other things, specifically in low and middle income countries about noise, which is quite different compared to the Western countries, for example, Western Europe and North America, is something what is honking. I mean, all of you may have experienced and can recollect many times, seeing, these kind of statements behind trucks and some of those, please honk, right? And most of the times in India, when people drive, they honk when they want to pass the lane, when they want to overdrive, when they want to caution, and when they are actually, whenever they want actually, right? For example, even at the traffic intersections, at the stoplights, many times you will see that people are honking. And what we did, we tried to look at what is the difference in the noise levels of a non-honking period to a honking period in Mumbai. It was near a major road, near in Powai, where our institution is located. One of my MTech students did it. And what you notice here are the typical 10 frequency ranges, which are of importance to human ear. And you can see that there is a significant difference in the noise levels during the honking in the low frequencies and in the high frequencies. And even though the graph may look like this is very, very small difference, but note that this is a logarithmic scale. Even something is 2 units higher, it is 2 orders of magnitude higher. Okay, so that is, it is 20 times higher, right? So that is very, very important to note. Now, with that, let's move and look at like how we can measure noise, or how we get this data when we are reported about noise. It's a very, very simple exercise. We can use something called a sound level meter. A sound level meter, which is here. It's a basic instrument which has a microphone. It has an electronic setup. For example, again, like human ear, this microphone senses the pressure, and that pressure is converted into an electric signal, which is converted to the logarithmic noise scale, which is again reference to 20 micro Pascal, right? So it's a basic instrument. When you can use it, it can give you the noise levels as absolute values of dB, and it can also convert them to a weighted scale like dBA, dBc, or dBb as the way we want. On the other hand, if we are interested in, let's say, an occupational environment, where 8 hours somebody is working at a machine, or for example, somebody is operating a bulldozer or some kind of an construction equipment, or for example, somebody is driving whole day, truck drivers, people who are in the traffic, policemen, all of those people are exposed to noise for very, very long period. So there, the concept of dosimetry, meaning that not only the noise level is important, but how long we are exposed to that is also important. For example, these kind of smaller instrument, which you can see here, can be put in the belt clip. They could be put in a bag. They could be attached, with their, collarbone somewhere with the shirt or so. And this can record the noise for the time period we are interested in. For example, 8 hours is the general averaging window for occupational environment, and this will give you the 8-hour average of the noise. So that is called, for example, noise exposure during occupational setting for the employees which are exposed to high level of noise. You remember I showed you the frequency distribution. For example, specifically, this is not used in general in the ambient environment. It is mostly used for when we are interested in control of noise, when we are interested in knowing what kind of noise any equipment is producing. For example, in hospitals, we don't want equipment which are high noise making. We don't want equipment at home, what we use are noise making. So when these instruments are made, the pumps which are running there, the other mechanical parts or electronic parts which are making noise. So we want to know what specific frequencies are being emitted from those equipment. and we can analyze them using an octave band analyzer, which gives you this frequency distribution, and you can then identify, what frequencies are being actually really like causing problem, and then we can work around some solution to dampen those, which is part of the control or the modification of the instrument. Okay, so there are 3 types of noise measuring equipment: a simple sound level meter, which measures the dBA point, or we can average this also for a longer period of time. We have noise dosimeters, which can measure for a given period of time, mostly for 8 hours in occupational setting. And we can have these the octave band analyzers, which are quite expensive compared to the others. And they are used mostly for engineering applications, for controlling and reducing the noise levels. Okay. Additional important aspect, and again, it is basic. So pardon me if this is really very simple, but I think it is important to look at that. For example, let's say you have 2 noise sources. Each one of them are producing 60 decibels. So what will be the resultant noise that's somebody who is exposed to it? What do you think? See, if it was any other water pollutants, it's arithmetic average. We just take them and we take an average. But for example, if it is noise, you can see the resultant noise is 63 decibels. And that is because this is already on a logarithmic scale. So if you want to add them, we need to convert that first into energy by taking the ND log, add the energies together, take the arithmetic average, and then take the average. Add the energies and then take the arithmetic average of those and take the ND log. So for example, the noise can be measured as, so this LP is the noise, and when we are raising it to the power of 10, this becomes energy, right? So this becomes energy, and we can add all different sources of energy, or maybe different time periods which are of interest, and then convert it back to a logarithmic scale, which will give you the resultant energy. So if you look at it this way, you have 60 plus 60, that you can also say it's 60 into 2, and if you just take the log, that is addition. So now 10 log 2, so 3 decibels. So basically you add 3 decibels to 60 decibels, that will be the resultant noise for 2 sources which are emitting the same amount of noise. Same thing is for the subtraction. You just, instead of addition, you subtract the energy, or let's say background energy. For example, many times we are interested in equipment, and there are companies like Bose, many others, which are really in this business and are telling about noise cancellation headphones and some of those. So they are actually playing about like how can we subtract the background noise from the signal and basically get you a clear noise which is of interest, and that is what we want, right? We can also look at it from a chart method. For example, adding decibels. Here, for example, if you want to add 2 noise levels, 55 and 51, you take the difference of these 2, 4 decibels, which is on the x-axis. So x-axis is the difference in the 2 noise levels, and the y-axis is the noise you want to add, L plus, you want to add to the higher noise level. So for example, 55 plus corresponding to 4, you have 1.4, if you add that. So resultant noise of these 2 noise will be 56.4 decibels. Same is for the subtracting. For example, if you have 60 and 53, the difference is 7, which is on the x-axis. Corresponding to 7, you have 1 decibel. You subtract that from the higher noise, so that becomes 59. So if that is the case, you will have a resultant noise of 59 decibels. What do you get from this? We get from this is when you have high level noise, if you subtract the low level noise, there is not much reduction that is possible. Okay, so essentially we need to work on high level noises. Now, how the noise is transmitted in environment, for example, it follows an inverse square law for point sources, simply telling that as you move away from a source, as we double the distance, 4 times the noise is reduced from a point source. On the other hand, if you are near a line source like a road or so, then it is only inversely proportional to distance. That means if you go double the distance, for example, double will be the noise reduced, right? There are like how the noise is transmitted in the environment. For example, that the noise is essentially sound, which is essentially energy, and which is absorbed by molecular excitation. And at the low temperature, it is by heat conduction. This is basically a table which is showing you how the noise is affected for different humidities at a given temperature between different temperatures and how each of these frequencies are affected. So what to note is, for example, sound absorption decreases by humidity. For example, higher is the humidity. For example, lower is the reduction in the noise. Same way, for example, higher is the frequency, more is the noise reduced. Okay, and the temperature has a kind of a specific relationship, which is like from 10 to 20 it increases, but then after that it decreases, because it kind of really complex in terms of molecular excitation versus heat conduction, that these mechanisms kind of contradict with each other. Let's look at why we are interested, which is about the health effects of environmental noise, which can be classified in terms of these broad categories like physical effects such as hearing defects, hearing loss, physiological effects like increased blood pressure, irregularity of heart rate, sometimes ulcers, psychological effects like sleep disturbance, annoyance, stress, night awakening, and it can also affect the work performance or the performance in the schools, for example, reduction in productivity, misunderstanding what is heard. All of those could be the cause of the effect of environmental noise. And we can also classify them in terms of what is affecting the human hearing and what is affecting the human activity. So for example, human hearing is the auditory effects, and the human activities are mostly the non-auditory effects, which are also what I said in the previous slide. Okay, let's look at the non-auditory effects of noise, which is mostly what we are affected with in the ambient environment. So whenever we talk about environmental noise, we are talking about non-auditory effects. So what I meant by that is, in general, people will not lose their hearing ability because they come across, they go to the market and exposed to traffic noise, or, some of the aircraft noise and some of those. People do not necessarily lose the hearing ability, but there are other effects which have been documented in a lot of research. For example, effects on cardiovascular system, for example, effect on blood pressure, effect on nervous system, which is related to the cognitive effects. It interferes with speech and concentration. It can cause annoyance, which can cause stress and fatigue. It reduces work efficiency. It can lower the morale. And sometimes high noise levels can mask warning sounds, for example, in the occupational environment. So these are some of the non-auditory effects of noise. Now, it is also important to note that even though we have this amalgam of kind of effects of noise, all of them have not the same severity and then not the same impact. For example, this is a pyramid of health effect of noise. On the bottom, you are seeing like feeling of discomfort, like a lot more number of people are affected, but severity is not much, meaning that you feel discomfortable. You don't feel like it disrupts a bit, but we don't care much about it. But if you go further, if this is like constant, at one point people start to see stress. For example, stress hormones are going to be released. People become more annoyed, right? That it's a smaller number of people compared to that, and severity is a little higher. But still, maybe we are not still seeking, some help. We are still not seeking medical help, for example. But a smaller portion of those people can then go to the next level where actual physiological risk factors can be seen. For example, increase in cholesterol, blood clotting, blood pressure, sometimes stroke, then insomnia, cardiovascular, things, heart rate, mortality, again, related to cardiac system. All of those could be like a very small part of the community. These are very severe effects, but you can see that like a range of people are affected and the severity is different depending on how much we are exposed, how long we are exposed. Something about noise pollution in Europe. What you can see here is about 125 million people in Europe are exposed to levels which are more than the regulatory standard, which is 55 decibels. And out of them, 20 million people say they are annoyed. 8 million people are having problem, sleeping. There are health impacts, meaning that people started taking medication, visiting hospitals, about 43,000, and 10,000 is attributed to a noise who are causing premature deaths, for example, which are related to hypertension, related to cardiovascular disease, which are mostly, attributed to noise. With that, let's move to what are the sources of noise pollution. It's very simple. I think you know, transportation system, for example, are the main sources of noise in urban areas. Interestingly, when we talk about noise pollution, we are not much concerned about noise in rural areas. There are other, big problems we may have in rural areas, but noise is not one of them. So it is mostly, you can say, an urban-centric problem or a peri-urban-centric problem. Then the other source of noise is construction activities of building, highways, because of the mechanical equipment, bulldozers, loaders, trucks. Then industrial noise, which is mostly in the occupational settings. And then you can have the range of what we call ad hoc sources, which could be sometimes operating, sometimes not. Loudspeakers, plumbing in homes, boilers, generators, air conditioners can also produce noise, fans can produce noise, vacuum cleaners can also produce noise, which which is unwanted. Maybe people don't want it, right? Now, if we look at the major transportation sources of noise, so this is basically showing you the noise level measured in dBA scale on the x-axis, and y-axis showing you how much percent of the people who are exposed to them are annoyed. You can see there are three curves. One of them is for air, another is for road, and third is for rail. What do you notice? You notice that as the noise levels increase, more and more people are getting annoyed, right? And this is not linear. For example, at higher noise levels, people are far more annoyed. Sorry, higher noise level, people are far more annoyed compared to the lower noise. And you also see that, for example, it is like the aircraft and so which have higher annoyance compared to the road or sometimes rail. And that is because you have aircraft noise which is not consistent. It is infrequent. And every time, for example, an aircraft takes off or passes, above our households or community, we are annoyed. On the other hand, a traffic noise, for example, on a busy road could be something in background. It's like almost becoming part of our life. So we are no more sensitive same way to these different kind of noise. If you look at aircraft noise and annoyance in this particular study, you can see that the reaction to the noise in different groups, for example, at low noise, no annoyance, to complaints, to some complaints, then appeals to stop noise, and then legal action at very high levels. Again, this is kind of showing you the same thing which we saw in the previous part. And also you see that there is like a range of noise levels for which the same complaint is being received. And this is because not everybody is same sensitive. For example, a person who is 65 years old has already lost some hearing ability compared to, for example, a working professional from 25 to 60 years of old who is more sensitive compared to some of the adults and children who are not worrying too much about noise. So many of the very old people and children may not basically complain about noise that much compared to, for example, working professionals in this middle range, right? If we look at roadway noise, it's like an example of line source, right? Because you have kind of like continuous noise which is really coming because of the vehicles, and this noise is a function of volume, type, and vehicle type and speed. Now, I think I mentioned it, but again to reiterate, if we look at the Western countries, what is the difference that we see in India compared to the Western countries? What we see is, of course, congestion, right, which is related to the speed, but the more importantly, we basically see honking. Like honking is one of the noise which is almost absent in many of the high income countries. If we look at the roadway noise or the traffic noise from vehicles, there are multiple sources which can contribute to that. For example, this aerodynamic noise, which is because of the friction of the air molecules against the body of the car, right? Then the intake of the air from the front of the engine, the cooling fan which is running, the engine, the transmission when we are changing the gears, the tire noise, which is because of the friction of the tire to the road surface, and the exhaust pipe when these pressured gases release from the tailpipe, there also we have the noise. So all of these together gives rise to traffic noise. And if you see here in these graphs, for example, in the first left graph, you see the frequency of the noise levels, and this is the typical pressure bands. And what you see is like there is a typical frequency range where you have maximum noise, and which is mostly when acceleration is happening. And at a cruise speed, for example, you have lower level of noises, right? Similarly, if you look at, for example, engine fan intake and exhaust, you can see that it is the exhaust which is the most dominant source of noise. And it's not a surprise that you have seen, for example, the mufflers which are used in cars, which are mostly used in motorcycles to reduce the noise which is coming from the exhaust pipe. So these are already the controls which are used to dampen or to absorb the noise which is coming from the exhaust pipe. Okay, moving further, if you look at the roadway noise and annoyance, this is very similar to what we saw earlier for the aircraft noise. As, for example, the noise level increase, then you can see that the dissatisfaction score, meaning that people who are annoyed, increases, which is very similar to what we saw for the aircraft, right? And typically noise annoyance increases with the increased traffic noise, similar to aircraft, what we saw earlier. If you look at traffic noise annoyance versus actual noise, it's very interesting. So we try to compare different cities, different levels. For example, you can see the annoyance is shown on the secondary y-axis and the actual levels are here. Ideally, you would expect that the higher the noise level, higher is the annoyance, but not always. And the reason is because it is about the sensitivity. For example, people in Sweden, Switzerland, some of those places are far more sensitive to noise, and even at low level of noise, they are highly annoyed. For example, compared to some of the other places where people are less annoyed, even for example, at higher levels. Let's move to noise control, which is very, very crucial. And it's a very simple concept. We are exposed to noise because of a source which is operating, and there is a path in between, and then we as receiver. So the control basically operates with this concept of looking at source, path, and receiver. So the solution of a noise problem may require modification of any of these three basic elements. For example, modify the source to reduce the noise. As I said, let's say source emission control. For example, we can change the engine design. We have already, like if you look at the faster speed trains, all of them look like, a snake, because this is an aerodynamic design which reduces the drag. And as soon as the drag is reduced, the noise is reduced. So by modifying the source itself, we are able to reduce the noise. Or for example, let's say we are working with a machine. So using certain parts in the machine which are absorbing the noise can basically reduce the noise itself from the machine, right? The other thing is like altering, for example, many times it's not possible. For example, ironsmith, for example, a construction worker who are working with heavy equipment, they cannot reduce the source noise. So they need to then maybe do something else. For example, we can do something like altering the transmission path, right? What are the examples? For example, in many cities, you have noise barriers. Somehow you stop, you put something in between before it goes to the community, before it goes to the receiver, right? For example, you can have, enclose certain machines into certain rooms, which are high level noise environments. Or for example, it can be also that sometimes we can, have administrative controls to, keep people away from the source wherever these noise are occurring, right? So those kind of altering the transmission. And actually the last in the ambient or in the environmental setting is, for example, using the double or triple glass windows. For example, if you have a single glass window, you still see a lot of noise which is coming, because noise conducts faster in the solid than the air, right? So what happens is when you have these double and triple glazed windows, you have this air in between these glasses, and the noise, for example, dampens. Almost like 10 decibel to 15 decibel noise can be reduced by using these windows. And those are specifically used, for example, in buildings which are near elevated corridors, elevated metro, or roadways. And even if we cannot alter the transmission path, we can basically alter it and give something to the receiver, something called personal protective equipment. I was giving an example of, let's say, construction worker, or for example, somebody who's working with a machine, a hammer, for example, in a forging industry. So there, you cannot have enclosure because the person is there working there. You cannot reduce at the source, but at least you can give them some kind of something like, for example, to safeguard them, like some personal protective equipment. I will talk about that very shortly. I think you can think about a lot of examples how noise can be reduced. For example, green corridors. Around the industry, there is requirement also many times that you need to have some kind of a buffer zone before people can, communities can settle or make their residences. I think all of that is again to, of course, to safeguard from the emissions, which are air emissions, also to the noise. So both of them, in that sense, it's a transmission kind of abatement. If you look at the roadway noise solution, so regulations limits, for example, as you saw, speed has a very important impact on noise. So at very high speed, the noise becomes very high. So if people are running at the cruise speed, they have definitely lower noise. Some regulations require vehicle to be properly operated and maintained, because you have seen old vehicles, for example, many times they make more noise. If you're properly oiled and service vehicle, make lesser noise, for example. And if we use these kind of regulations, we can reduce noise to about 5 to 10 decibels, but not beyond that. So what can be the other solutions? We can have barriers like buffer zones, wooden fences, concrete walls, vegetation. If it is dense enough, this can be also used. For example, sometimes these barriers may not be like, very odd looking. They can be aesthetic also. For example, this one, which is in Melbourne, Australia. Then the other thing could be also in terms of the pavement types, because certain asphalts, those containing rubber or stone, can be less noisier than the other pavements. But there are other studies that they say that this noise is not much reduced and more research is needed. You also, if you remember, I showed like how the exhaust noise is the most important one when it comes to the road traffic noise. So somehow we need to work more on the vehicle design and the kind of noise control we can have for the exhaust pipe than, for example, the other kind of controls. So far, we looked at the environmental noise in ambient environment where general public is exposed. I will take maybe about 10 or so minutes, maybe at max, to also kind of really look at the noise levels at occupational environments. So noise at the workplaces. Because the kind of noise we are exposed in general environments are significantly lower than compared to what people are exposed at the workplaces. That's one. Second, at workplaces, workers are exposed to these loud noises for a long period of time. So which again, makes them vulnerable and, essentially can cause adverse health effects. So if we look at workplaces, loud noises can cause hearing loss. So essentially, when we talk about auditory health effects, most of the time we are talking about workplaces. This is not happening in the general environment. Prolonged exposure to harmless noise can cause hearing losses. And interestingly, this damage for hearing loss is irreversible because there are some kind of nerve damage which cannot be reparable. And on the other hand, this can be preventable. And the prevention involves some kind of noise controls, safe work practices, and educating the workers who are working there, and also the managers and the people who are managing the workplaces. So what are the effects of loud noise? For example, it can cause hearing loss over time. As I said, it can damage the nerves permanently, cannot be treated, and the effects are mostly seen at the high frequencies first, and then they progressively go to lower frequencies. So for example, many times people in the construction business and blue collar jobs, when they reach towards their 50s or so, you will kind of hear, them saying that, George, speak louder, I'm not able to hear. And that is because they have already started, losing their audibility. And one of the other effect of loud noise is something called tinnitus. It's like some kind of a permanent ringing in the ear, some kind of buzzing, and it really disrupts them because it can disrupt sleep, reduce their concentration, it can annoy them, and sometimes they can also go to depression, right? So these could be the effects of loud noises. Now, when can be a noise exposure too loud? We already looked at the noise scale, which is from 0 to 140 decibels. But if we look at, for example, in the workplaces, it is like 8-hour average noise, which is exceeding 85 decibels, is described as the regulatory standards. And this you can kind of visualize or think about it this way. If two people are 3 feet apart and they have to shout to be heard each other, then the background noise is very high and probably it is more than 85 decibels. Know that exposure to noise levels which could be above 115 decibels even for 5 minutes is very risky. And for example, noise at 140 decibels can cause pain and immediate damage to nerves. For example, those which are with the gunshots or very in proximity to aircrafts. That's why when you have seen, when you board any aircraft, you will see all the crew which is around the aircraft always have some kind of a like earbuds or some kind of a noise cancellation kind of equipment around their ear, because it is like very dangerous to their ears if they are not using that. Now, examples of noisy equipment, for example, these are all in the workplace environment. Mostly you can see mechanical equipment which can have noise levels all the way from 85 decibel to almost like gunshot, which is 140 decibels. And we can always come across these kind of noisy environments, our noisy equipments around our homes, especially during the construction business, construction practices, sometimes loudspeakers and so, but those are not noisy equipment. They are like some random activities. But at the workplaces, I think we come across some of these quite often. Now, there is something called audiometric testing, which is like something like called a hearing test. I think many of you know that when we go for a driving license, our ears are tested because we need to have good hearing ability if we want to drive, because not only we want to make sure, the driving school or the RTO or the Department of Transportation not only want to safeguard yourself, but also the drivers and the people around. So good eyesight and good hearing ability is an important thing. Same thing is also done in the workplaces. For example, trained technician can identify the hearing loss. For example, people can be put in some kind of these audiometric chambers where different frequencies of noise are introduced, and they are asked to tell whether they are able to hear them. And this is like how a typical audiogram looks like. This is the frequency, this is the hearing level. For example, a normal person with normal hearing will be like within 10 decibel he should be able to hear, or he or she should be able to hear all frequencies. But if we look at, for example, a person with mild hearing loss, I told you like initially the noise hearing ability goes for the higher frequencies. You can see that, for example, you have to increase the frequencies to almost 40 to 50 decibel when they can say that they are able to hear it, right? So for example, what they could actually normally hear at here, you need to raise that noise to this level for them to hear. And if you want to look at severe hearing losses, which could be in some occupational environment, almost this person will not able to hear anything. They need some hearing aid, and probably they are not good enough to work in certain kind of job profiles. And something called a standard threshold shift is what is used. So if people have more than 10 decibels of average loss in 2000, 3000 and 4000, which are the most important noise frequencies for hearing human conversation and all activities, then we say that there's a standard threshold shift, meaning that a person is having effect in their audibility. So what kind of occupational noise control? Very similar to what we said earlier, just that you can have enclosures, barriers, mufflers, noise absorbing materials, and hearing protection, right? Isolating, for example, the noise source, use of acoustic design, installation of panels or enclosure around the noisy sources, having a green belt around, right? Some of those could be important noise control in occupational settings. As I was telling, the hearing protection is a must. Most of the occupational environment, ear muffs, ear caps, or ear plugs can be used, and they should be engineeringly designed. For example, cotton doesn't work because it doesn't, reduce or doesn't abate any kind of noises which are impacting us. At the same time, not only that we need these protective equipment, but the proper use and training of those are also important. And I just give you, for example, something similar. If you look at these times which we are going through, which is this COVID-19 time, which is affecting all of us personally as well as, at our professional ends, you would see that even if like the general advisory is to use masks, you will find people not using masks. For example, when they are talking on phone, when they are outside, they are running, they are basically keeping their nose outside. And that is like kind of like, you are not using it. It doesn't mean like whether to have or not have, for example, a mask. Similarly, like if these earplugs and earmuffs are not being properly used, there is no use of having them. The other example is, for example, the helmets. For example, you will see that the helmets are for our own safety, or for example, you can see also the seat belts. All of these are regulated. These are told that people should use it, but you will many times find that people just hang their helmets on the the handle of the vehicle, of the motorcycle. So essentially, like, and in case of noise, it becomes extremely important, because even 1 minute of exposure to very high level of noise can affect the hearing ability. So that becomes very crucial in case of noise, right? As I was saying, 1 minute of unprotected exposure at levels more than 115 can severely damage our hearing ability. A last almost slide on portable radios, CD players, iPod, and iPhones. These devices do not provide protection. Okay, they are basically to transport the noise from a device to your ears for the sound we are interested to listen. And many times we are exposing ourselves to high level noise, which is more than 85 decibels, because we are using them at public places where the background noise is high, right? So essentially they are adding to the background noise. I mean, these days noise cancelling headphones are there, which use some kind of noise active control. But again, they can only work at the lower frequencies. They cannot work at the higher frequencies. So just to keep that in mind. With this, I'm going to just end this talk today. So at IIT Bombay, we have like several research groups which are working on environmental pollution research. For example, we have two big departments. One is Environmental Science and Engineering Department. The website is given here. There is a YouTube video you may want to look at. And also we have the interdisciplinary program in climate studies, where many people work also on environmental pollution. And there is also another video which you want to look at. If you have any questions, of course, I am really looking forward to answer them now. Also, later you can approach me through this email. And I just want to thank you for your attention to this lecture. And I'm ready to take any questions that you may have. Thank you.
Thank you, sir, for letting us know about the environmental noise and its link with sustainability, and also putting light on urban noise levels in the world and how it affects the death rates. And also thank you, sir, for sharing the links of resource materials too. There are a few queries from the participants' end. And the first query goes from Mr. Lomesh Mahajan. And the question is like this, sir. Can we measure noise with mobile sensors?
Okay, very good. Yes, we can measure noise with the mobile phones. I mean, if the mobile sensor means mobile phones. But the problem is these are not scientific equipment. So it will basically measure any noise. And it is not filtering the noise. It is not giving you any weighted score. So I suggest that, for example, the mobile phones could be calibrated to a standard sound level meter or an octave analyzer, and then it can be used as a portable device to measure noise. Yes.
Thank you, sir. The next query is from one of the internal faculty. At what distance the noise dosimeter is placed from the source to get accurate value?
Okay, so noise dosimeters are only for like within the vicinity of the person who is getting exposed, because dosimeters means what is the dose of the noise which is being received. And as if you remember, I mentioned like how the noise changes or reduces as we move away from the source. So as soon as we have moved double the distance, already the noise has reduced by 3 decibels, right? So dosimetry cannot be done away from the source, away from the person. So it has to be within, like it should be at the body of a person. So that's how the dosimetry can be.
Okay, sir. The next query is like this. How GIS is used to predict the noise levels at various places?
Wonderful. So yeah, essentially like know that geographic information system is a wonderful tool. It's a spatial tool, right? So which basically provides multiple layers that we can superimpose over each other. So as long as you have some kind of noise measurements or some kind of noise propagation models, which can give you, let's say, some hotspots, right? So then we can superimpose the other features like, residences, building density, traffic network, the land use. And based on that, we can actually tell which are the areas, where we have higher noise, where we have low noise, even if we may not have measured it there. I think there are already what we call different spatial interpolation schemes like Kriging, for example, inverse weighted square scheme. Those could be also used, which are simple thing. For example, I showed you the Bangalore, Bangalore city, where let's say 10 or so places noise is being measured. Now you can use an interpolation to basically, assess the noise in between all the areas, and you can come up with a map which could be integrated with a GIS platform. So yeah, I think GIS is going to be a very useful tool also for noise. Yeah.
Okay, so thank you. And the last question goes like this. How can we relate noise pollution to sustainable development?
Yeah, I think that was absolutely. I think we want to really definitely go back there. So the whole idea of sustainability is what? The sustainability is that we should use our resources in such a way that not only we are able to use them, but we are able to preserve them for our posterity, right? Now, because all of us are also interested in our lifestyle improvement, use of comfort. For example, we want air conditioners, we want to use traffic, we want to travel by aircrafts, right? We want to travel by trains, high-speed trains. We want construction activities all the time around. All of them lead to noise. So I would say the relationship between sustainability and not only noise, any kind of environmental pollution is this. If we are able to develop our society, whether this is smart cities, so then it is smart transportation, which will basically enable like the levels of pollution, both air and noise, below the standards, so that it doesn't affect our health adversely. If it doesn't affect our health adversely, then we are more productive. We are not spending our money for the health cost, and not going to the work, but we are able to use it for other important things. And also, for example, mining activity. So if we are able to mine in such a way that we can able to preserve it for future, so I think the relationship is very simple. The relation is, as long as we are producing any pollutant, any stressor more than that we is affecting our health, it is affecting sustainability. Because even if we can safeguard ourselves, but like many others who are disadvantaged, who are not able to afford the same kind of control that we can, are getting affected, and this is like affecting the sustainable development, right?
Yes, sir. Thank you so much, sir. These are the queries from the participants in. And also, if any further queries from the participants, kindly share it with us, your registered email ID. And also, you can share it with Dr. Harish and get back to you with your answers.
Yeah.
And now we have come at the end of the session. I request the participants, you can watch the video and also submit your feedback form. And the link will be open till 5 p.m. today. May I now request Professor Dr. Shilpa B.S. to kindly propose a vote of thanks. Over to you, ma'am.
Good afternoon, one and all present here. As we have come to the end of today's webinar on urban noise pollution, sources, impacts, measurement and control, it's my privilege to propose the vote of thanks on this occasion. On behalf of our department, I acknowledge and convey my heartfelt thanks to the resource person, today's speaker, Dr. Harish C. Puleria, Assistant Professor, Interdisciplinary Program in Climate Studies, Indian Institute of Technology, Bombay, for sharing the knowledge and experience on the urban noise pollution. Thank you so much, sir. I take this opportunity to express our sincere thanks to members of management, VIDYAVARDHAKA Sangha, and our principal, Dr. B. Sadashivagoda, who have always been the great support for conducting such events. Thank you all. I express our earnest thanks to the Dean Academics, Dr. H.S. Dayananda, for supporting in organizing the event. Thank you, sir. It is a matter of immense pride for me to convey my gratitude to our HOD, Dr. H.K. Prasad, for his continuous support and motivation in conducting such events. Thank you, sir. I render my sincere thanks to the coordinator, Dr. Umesha P.K. Thank you, sir. I would also like to render our heartfelt thanks to the moderators, Professor Anjan and Professor Arjun V, for helping in broadcasting this event, Professor Sharmila, Professor Abhilash, Professor Kanmani, and Professor Manoj for publicizing the event. And I thank all my fellow colleagues, technical and non-technical staffs who helped in conducting this event. Thank you all. I would like to thank all the participants for their kind cooperation and see you all tomorrow morning for the concluding session at 11 a.m. for the next webinar on energy efficiency and green building by Dr. N. Gopalakrishnan, Director, Central Building Research Institute, Roorkee. Thank you, one and all.
Thank you very much.
Thank you, ma'am. And on my behalf, I also thank all the participants for your active participation in today's session. And I expect the same enthusiastic participation for the last day session, that is tomorrow also. I also thank the speaker, Dr. Harish Puleria, for sharing your knowledge and sparing your valuable time with us, sir. Thank you so much.
Thank you. Thank you.
I, Madhushri, signing off from the Master of Ceremony. Thank you, everyone. Stay safe.
Okay, great. Shilpa, can I ask you a question?